All right. So if I look at number 56, Troy, which side were you thinking?
The left side.
I would agree. Now, the right side might look a little bit more complicated, but when I see like the squared here and no squared here, that to me says I got to factor and reduce. I'd prefer not. Remember, if we said this way was going to be a factor, the other way, going the other way should be a FOIL. And we'd prefer to do foiling over factoring. I think that's right on. That's what my plan would be. So let's say we start with the left-hand side. Now, again, I notice that I have like things to the first and then things to the second. So I'm probably going to think to myself, multiplying by, or making one of those difference of two squares is going to be a good decision here. The question that I'm uncertain about is, should I do sine x plus cosine x to the top and bottom, or sine x minus cosine x to the top and bottom?
Second.
You want to do plus? I agree. I think we do pluses. I'll tell you why I see that in a second. So the numerator, when I FOIL this out, is going to be sine squared minus cosine squared. Now, I didn't really FOIL that. I used that difference of two squares factoring pattern to do the multiplication quickly. If you struggle to remember that, you could always FOIL, but that's what I did there. The denominator, though, is just going to be a regular old FOIL. So sine times sine is sine squared. Sine times cosine is sine times cosine. Cosine times sine is just cosine times sine. I'm going to write it, though, with the sines first. And then cosine times cosine is cosine squared. Now let's take a look at where we're trying to get to here. In the numerator, I need two sine squares, right? I see I have one of them already. Is there a way to make cosine squared into a sine squared? Yes, right? That's using P1. So remember that cosine squared is 1 minus sine squared. But I have to be pretty careful here because that minus sign in front, I'm going to have to distribute. We'll do that in a second, though. I want to look at the denominator now. So if I look at the denominator, I have a 1 that I have to get in here somehow. Let's look at what I have in my denominator. I notice that I have a sine squared plus a cosine squared. That's going to give me a 1. So I'll do P1 again in the denominator this time. And then I need 2 sine x cosine x as well. I have them added together. I have a sine x cos x plus a sine x cos x. Well, that's just going to be 2 sine x cos x's. Troy, so far so good?
Yeah.
Okay. If I then distribute the negative in the numerator, I'm going to get minus 1 plus sine squared. And I notice, hey, sine squared plus sine squared, that's going to be 2 sine squareds. And bingo, bango, bongo, that's what we needed. Does that feel okay? Again, I'm really trying to illustrate to you like what my thought process is when I'm working through this. Like, what am I going back and doing? How do I know how to proceed? What am I seeing in the problem to let me know what to do? Trying to help you build out kind of that toolbox of like what are good things to do or what are kind of bad things to do, or how do you know the difference? So I'm trying to do as much of that like internal dialogue that I'm having with myself out loud as possible when I'm explaining what I'm doing. I want to give you the why as much as possible, because it really makes these problems a little bit easier if you've like can start to see the patterns like I see the patterns. And now that you won't be as good as me, because I've been doing this for 20 years. You've been doing this for 2 weeks. It takes a long time to get good at it, but like you can get good enough at it in 2 weeks to where we can do these things effectively. And I'm trying to like, you know, hold your hand and lay the breadcrumbs down as best I can to help you find your way through this, since it's not just like this is the process, do this every time kind of thing. Who else? Happy to do more. Marianne. 50, sure thing. So should be no surprise which side we want to work on, right? Nobody wants to work with the 2 and try to build that out into these terrible looking trig things on the other side. We're going to start on the left-hand side. So there's no good identity to do. I mean, you could do reciprocal things, but I don't want to make fractions if I don't have to, especially when I see the 2 over there. I'm guessing that I'm going to have sine squareds plus cosine squareds is what I want to see. So I'm going to start by just dealing with the exponent there. Remember, if I have an exponent around the parentheses, what that means is that you really just have that parenthesis twice. So this, when we look at this, should look like a FOIL problem. Ariane, are you good with what I did there as the first? Okay. Then we'll FOIL out. So cosine times cosine is cosine squared. Cosine times negative sine is just sine times cosine. Well, negative sine times cosine. Negative sine times cosine is another negative sine times cosine. And then negative sine times negative sine is positive sine squared. And we'll keep on going. We're going to get the same things, except now everything is positive, right? Because it's basically the same thing. Shrink that down a little bit so I can fit this in, because it's getting kind of big. Mr. Kulik, this looks so terrible. You know what? It's always darkest before the dawn. All right, so let's look at what we can do now. We got all this stuff in here. Let's see. I see a cosine squared and plus a sine squared. There's a 1. I see a negative sine times cosine and a positive sine times cosine. Those can just cancel. I see a negative sine times cosine and another positive sine times cosine. Well, those just add to give me 0. And then I see a cosine squared plus sine squared. Well, that's 1 also. And there's my 2. So I did P1 twice there. What do you guys think? Ariana, you happy? If you have a sine squared plus a cosine squared, that's 1. But if I have a negative sine times cosine and a positive sine times cosine, those just cancel out, right? It's like negative 1 plus 1. You just get 0. So, okay. What I did was this one and this one, I have a negative and a positive. Those added to give me 0, right? And then I did the same thing with this one and this one, where those added to give me 0. Is that easier to see? Okay. But yeah, if you have a negative sign plus sign, that just is 0. Ava. 62. Sure thing. Oops, that's not what I want to do. All right. So if we take a look at this thing, it certainly seems to me like the more complicated side is the left-hand side, correct? But again, if I look at the numerator on the left-hand side, I see like squared things. If I look at the numerator on the right-hand side, it's to the first. What that tells me is that I'm going to have to do factoring if I use the left-hand side. And if I'm doing factoring on the left, if I use the right, I'd have to just end up doing foiling. So I'm going to choose to do the right side here so I can avoid the factoring. It's okay if you go that route. It's still eminently doable. But I don't want any part of it. So I'm going to actually choose to use the right-hand side here so I can avoid the factoring if I can. Ava, does that make sense as to what I saw there? Okay. So to decide what I want to do first, well, probably the denominator is the clearer piece. So I see a 1 minus cos. Almost every time I see something like that, I'm going to probably want to multiply by the conjugate to get the other half of that difference of 2 squares thing. And I remember that when I do that, it's going to give me like a 1 times or a 1 minus cosine squared, which is the sine squared over there that I'm looking for. So I think I'm going to want to do this first. I avoided doing it with this one because of the 4 there. Usually that's not going to work out real nice for my using a Pythagorean later if there's a coefficient on there. So given the choice, I would probably pick the one without the coefficient to do the difference of 2 squares thing with. Ava, does that make sense as to what I saw there? Okay, so now it's just like time to do some foiling. So when I FOIL the numerator, 1 times 1 is 1. 1 times cosine is just cosine. Negative 4 cosine times 1 is negative 4 cosine. And negative 4 cosine times cosine is negative 4 cosine squared. On the bottom, I get 1 minus cosine squared. That's just me using that difference of 2 squares pattern. All right, let's take a look at what we got now. If I look at the numerator, I have my 1. I have my minus 4 cosine squared. So that's telling me that the negative 3 cosine has to come from this stuff. And hey, if I just combine the like terms, I'm going to be good, right? So that numerator is locked and loaded. That's done. That's great news. As soon as I see that, I'm quite confident I've made the right decision as which difference of 2 squares piece to multiply in the beginning. If that didn't work out for me, I might have rethought and started over and tried the other one. Ava, still doing good? Okay. Next thing I'll do is I'll look at the denominator. So I have 1 minus cosine squared. I need to get sine squared. Well, I recognize that guy. That's just P1. So I'm dunzos. That feel okay? So again, if you had chosen to work on the left-hand side, the factoring there is not trivial. You know, you have a quadratic where the leading coefficient isn't 1, so the factoring is a little bit more involved. Still eminently doable. You all learned how to do that kind of factoring last year. Do you remember it with mastery at this point? Probably not. If I had my choice, would I rather skip having to do that and just do some foiling? Yes, sir, please. Thank you very much. So a lot of this is going to be, can you recognize what's going to be less painful in terms of choices? Nicole? 57. Can this be our last one, and then we'll do the quizzy? You guys okay with that? I have some good news when it comes to the quiz, though. All right, Nicole, which side did you want to work on? The left side. Okie doke. I think maybe the right side would have ended up being clearer what to do, but I don't blame you. I think that probably one of us would have chosen the left side on instinct, and that is okay. So if I look at this, I see everything in sines and cosines already. Well, that's nice. But it doesn't seem terribly obvious what to do. There's no good identity to think of doing right away. There's no like terms to combine. It's already one fraction. What I'm going to do is I'm going to think about a little bit about what I have here. I know tangent of A is like sine A over cos A, right? So if I look at this piece, if I divided that piece by cosine B squared, I'd end up with that tan A that I need there, right? So I'm going to do this to the top and bottom. So far, so good, Nicole? Okay. If I then look at this piece, I want to turn that into tan B. Well, tan B is sine. Oh my gosh, here, guys. Tan A is not sine A over cosine B. It's sine A over cosine A. So I'm going to just multiply the top and bottom by cosine A. Yeep. Okay with that? All right. Now let's look at this one. This is sine B over cosine B. Okay, well, I have the sine B already. So let's multiply this top and bottom by 1 over cosine B. And that'll get me my tan A and tan B. Everybody okay there? Let's just see how that works out now, okay? Because I've probably done enough here that it's going to be tough to see. So when I multiply here, and then it multiplies to there. And then this one multiplies to there and multiplies to there, right? Okay. So when I multiply this one, the cosine A here is going to cancel with that cosine A there. And then this cosine A and that sine A are going to make a tangent A. So I'm just going to write that part. Now when I multiply this guy to both places, over here, this cosine B is going to cancel that cosine B. And over here, this cosine A was gone on the first pass, right? So I'm going to have sine B over cosine B. That's just going to give me tan B. I really like where this is heading, right? Because I've already got the numerator to kind of tumble out of there. All right, let's see what happens when we deal with the denominators. So when I multiply here, the cosine A's are going to cancel. And when I multiply here, well, sine A over cosine A is going to make tan A, right? Okay, so I do that. When I multiply here, the cosine B's are going to cancel. And I multiply there, the sine B over cosine B can make a tan B. And this stuff all went away, so all we're left with there is a 1. And I think that's it, right? So that was tough to see. I think if we started here and then just cleared the fractions, so multiplying the top and bottom by like cosine A, cosine B, it's a little bit clearer how to get to here, but still doable, right? What was the kind of the key was thinking about what is tangent A and tangent B really, and like, okay, let me just make tangent A where it needs to go, right? What do I need to multiply this thing by to make a tangent A there? And let's multiply it out and see what happens. I don't have to think further than that. I don't even have to necessarily look at the second one, right? Like I need to get rid of the cosine B and add in over cosine A, and that would have been enough. Let's just try to do that and see what happens. And if you get it, oftentimes like everything happens exactly the way you need to, and it's like, oh my God, this is working out perfectly. And all I did was really look at the first chunk. Well, that's a confusing looking mess of drawing, but probably made sense in real time. Okay. How are you guys? Yeah, we're okay? All right. I need you guys, you can take out your identity sheet and you get a partner and you get you can have up to 3 hints from Mr. Kulik if you're stuck and you're just like, can we have a hint here? Okay. So the partners are assigned here. If you are one person, you can join any group of your choice, up to maximum 3 people per group. I don't think we had any absences today, so Ava, you're the only one. So you can pick any group that you'd like to work in. Once you guys have gotten up and moved and found a place to work together, I'll come by and drop a quiz at your guys' partner desk. Everybody cool? Okie dokie. I don't know that we have, do we have one identity? You got the last one? Okay.